Alright, so today what we're going to do is we're going to look at combining like terms. Now, combining like terms, terms with the same variable raised to the same power. This is really important that you understand what this is, so I'm going to go back over it again just to make sure you have that. Like terms are terms with the same variable raised to the same power. Okay? Super important that you understand that so that you can do this correctly. Alright, the other thing you need to know are, what are terms? Well, terms are separated by addition or subtraction. So anytime you have that addition or subtraction there, you have terms that are separated here. Okay, so I've set up kind of like this cheat sheet to help you understand what you're looking at. Okay, so 2x plus 3x, those are like terms because they have the same variable, x and x, and they're raised to the same power here. Okay? Remember that if there's not a power there, that's always 1. So 2x plus 3x, I could combine those two things. Okay? Because they have the same variable raised to the same power. Now here, unlike terms. This is an x, this is a y, two separate variables. You can't combine those things. Okay? Down here, again, unlike terms. 5 plus 3y. That has a variable, that doesn't. I can't combine those. Okay? Those are unlike terms. And then down here, unlike terms, 2x plus 3x squared. Now the variable's the same, but they're not raised to the same power. This is raised to the first, this is raised to the second. So I can't combine those things. Okay? Super important because a lot of people try to combine these. A lot of people try to combine these, and you can't do it because they aren't like terms. Okay? And this is stuff that I've been seeing on y'all's papers and how you've been doing things that you've been trying to do this incorrectly. So now we're going through this to make sure we have this correct. Okay? So like terms, terms with the same variable raised to the same power. Alright? So now we're going to do some practice problems of combining these together. Alright? So we're going to go through, I've got a whole bunch of problems we're just going to go through pretty quickly. We're going to combine the things that are the same. Alright, so here, 7m plus 4c plus 4c plus 8m. Now again, same variable, same power. Those things I can combine. And they're terms because they're separated by addition or subtraction. Okay? So, because these are all addition, now I can use my commutative property and I can rearrange this problem. So I'm going to kind of show you what that looks like and what's really happening, even though you probably won't actually do this on your paper. I'm going to show you real quick exactly what's really going on. Alright, so 7m plus 8m. All I'm doing is I'm putting my like terms together. That's what I'm doing. I'm reordering so I got them together. 7m plus 8m plus 4c plus 4c. Alright? All I do is put them together. Now, a lot of us are going to go, oh, okay, so that's a like term and that's a like term. So 8 plus 7, that's 15m. And that's fine. But you have to understand that you can do this and you got to understand why you can do it. Right? So our commutative property lets me do this. So now 7m plus 8m, 15m plus, again, like terms, I can combine them, same variable, same exponent, same variable, same power. 4c plus 4c, 8c. But I can't combine these two things because they're different variables. So m and c, I can't put those together. So here would be my answer, 15m plus 8c. That's all there is. Now when we come down to here, this is another one, 2w plus 1 plus 3p. Same variable with the same power. Well, none of those have the same variable. If they don't have the same variable, give that answer back to them. That's their answer. 2w plus 1 plus 3p. There's nothing you can do to that problem. You can't combine them. So, just give them back that answer. No problem there. Alright, come up here, 10b plus 2b plus 3x. Same variable, same power. I'm going to keep saying that so that it sticks in your head. 10b plus 2b plus 3x. Oh, these two have the same variable to the same power. I can put those together. 10b plus 2b. 12b plus, and I can't just drop this off. That goes with it. 3x but I can't combine those because they have different variables. So there would be my answer. Okay, that's all there is to it. All right, so now we come down here. 4k plus 12k plus 12a plus 7a. All right, well, same variable, same power. K, there's a k, 4k, a k, but what's in front of this one? Well, there's a 1. If there's nothing in front of it, there's a 1. So 4k plus 1k plus 12k. So all of those I can put together. So 4, 5 plus 12, 17. 17k plus, and then I'm going to come over here, 12a plus 7a. I can combine those two together also. 19a. So now I can't combine those. Different variables, different exponents. Okay, 17k plus 19a. That's all I can do to that one. That's all there is. All right, so now, remember, same variable, same power. Now when I'm looking at this, I've got one that has all the same variable, but I have it raised to different powers inside of here. Okay, so whenever I'm doing this, I'm going to put together the ones that have the same power, or same variable to the same power. So 5a squared plus 2a squared plus a plus 3a. And all I do is rewrite it so that my like terms are together. Now, guys, remember, some of these are going to have subtraction in them. They're going to be negatives and things like that. I've primarily showed you positive ones at this point, but these could be negative, these could be positive. They could have addition, they could have subtraction. Okay, it just depends. But I'm going to combine these. 5a squared plus 2a squared. 5, 6, 7. 7a squared. Notice I really don't do much with this, okay, with the variable. I'm just kind of combining the coefficients, okay, the numbers in front of the variables. 7a squared plus, what's in front of that? A 1. 1 plus 3, 4a. And I cannot combine those because this is a to the second power and this is a to the first. All right, next problem. Now look here. 4x squared, 2x, 3, 5x squared, 7x, and 8. All of those are terms, but they're different terms. So let's put the ones that are alike next to each other. 4x squared plus 5x squared plus 2x plus 7x plus 3 plus 8. Now I can combine this. Okay? 4x squared plus 5x squared, same variable, same exponent, yep. 9x squared plus 2x plus 7x, 9x. So those two plus 8 plus 3, 11. And now I cannot combine all of these because they don't have the same variable raised to the same power. That one doesn't even have a variable, so you can't combine that. All right. Now we're starting to get into where they have the distributive property attached to this. All right, so this is the goal. We're to go through all of that and start getting to where we can start simplifying larger expressions using the distributive property and using the like terms. Okay, so that's the goal of what we're doing. Okay, so what we just did was making sure we knew how to combine like terms. Now we're going to start implementing it into larger expressions and dealing with the things that we've already done before. All right, so here, 12x plus 8 parentheses negative 4x minus 10. Well, I can't combine the 12x and the negative 4x yet because I got other operations going on here. Okay, so until I can deal with these other operations, then I can't combine it because you have to do orders of operations first. Okay, notice that when you're doing combining like terms, it's addition and subtraction. Right? Now you've done all this other stuff, you're down to just that. So I have to get down to just that so that I can combine my like terms. Well, here, I can't combine those two because they're not like terms. But what I can do is I can use my distributive property and distribute that 8 all the way through there. that lets me get around not being able to combine these first. Okay, so that's what I'm gonna do. I'm gonna take this 8, and I'm gonna distribute it through. Okay, first thing I'd probably do is change that from subtraction to addition. So I'm gonna do that, click, 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 click. All right, so now I'm gonna multiply 8 times each term inside of there. Any term is separated by addition and subtraction. So 8 times negative 4x. So what I'm gonna do is I'm gonna bring this down, 12x plus 8 times negative 4x, negative, nope, that's not right. Negative 32x plus 8 times 10, 80, and because it's negative 80. Now I have all addition, and I can start combining these like terms here. So now I've got this 12x plus negative 32x. Well, sign rules, positive plus a negative, subtract, keep the sign of the bigger number. So here, I'm going to subtract, keep the sign of the bigger number. So I know right up front, it's negative. Positive, negative. This is bigger than this, so it's going to be negative. So now all you got to do is subtract these two. 32 minus 12 gives me 20, and then I bring down my variable, my x, because that's combining of the like terms. So now I got negative 20x, but I'm not done because I still have another part up there. Plus negative 80. Okay? So it may look like that, or it may look like this. Depends on what you're getting back in your problems. They're the same thing. They really are. They're the same thing. So pay attention to what you're getting back. All right. This is the ultimate goal, to be able to start doing these types of problems. Now this one. Negative 8, parentheses 3x plus 3, parentheses plus 19. Again, I can't combine them because I got these parentheses here and I got other operations. So use my distributive property. It lets me get around this. So the negative goes with the number. Negative 8, negative 3. So negative 8 times 3x, negative 24x, plus negative 8 times 3, negative 24, plus 19. That's just the distributive property right there. Now I'm going to combine like terms. Well, there are no like terms with negative 24x, so I'm just going to bring that down. Plus, negative plus a positive, subtract, keep the sign of the bigger number. 24 minus 19 should be 5. Negative because negative 24 is bigger than 19. Okay, so negative 24x plus negative 5 can also be written as this. Either way. If I'm grading it, I'd accept either one of those. They're the same thing. I want you to know that they're the same things. Okay. All right. Same type of problem, except now I got negative 20y out here, but I can't combine it. There's nothing around that I can combine it with, so I'm just going to bring it down. Negative 20y plus, use my distributive property. Go right here. So 3 times negative 2y. Now look here. They already have this as a plus negative 9. Okay? I didn't have to change that, so I don't change this. Okay? I only change this if it's a subtraction here. If this would have been a subtraction, then I would have went in and did click, click. But it's not, so I don't do that. All right, so 3 times negative 2 gives me negative 6y plus 3 times negative 9, negative 27. Remember, a positive times a negative gets you a negative. All right, now combine like terms. Well, I've got a negative 20y plus a negative 6y. Signs are the same. They're being added. You combine them, keep the sign. Negative 26y plus negative 27. Looks like that. Also could look like this. Either way, same things. All right, guys. If you need help with any of this, you have a few questions, just get stuck in a problem, let me know.